So today I will teach you about the wave function and more about the probability density. Wave function is actually the probability amplitude, and the probability density is the actually the describes the probability of finding an electron in a given space of volume. And in one of the previous lectures, we have already derived these equations. This is the wave equation, and this is the probability density. And this is all about the wave function in the translation motion and the probability of finding electron in the translation motion. So similarly, we will move with the other rotational and the vibrational movement. So in this lecture, later on I will discuss about how to find out the difference in the energy, which is the quantized kinetic energy, and what would be the general equation for this one. It would be very simple equation, and actually it is the all about we have already discussed in the previous classes. So here I am just extracting all this knowledge to apply over here to get the generalized form for the quantized energy level. And this is very important for the translation motion, because you will get the lambda max or the wavelength by using the energy mean energy of the movement of the electron from energy level 1 to energy level 2. And there may be any energy level, maybe the electron is going to jump from energy level 1 to energy level 3. So this we will discuss detail in today lecture. So here, these are the three diagrams, and the first one, A, this is the energy levels. Energy level for a particle in a box with the length from 0 to L, and there are the three energy levels are mentioned over here: energy level 1, energy level 2, and energy level 3, and it will move so on energy level 4, 5 in a similar way. So in the second diagram of the figure, it is the wave function, and this wave function showing the the ground state and the two excited state, and similarly it will further move to the third excited state and the fourth, and so on. So this is actually the wave function, and the third one is the probability density. Actually, this is the the probability of finding the particle in a at a particle point in a box, and the length of the box is from 0 to L. So let's have a further discussion over here. So what is the energy level 1? And I am just going to further generalize and to find out where is the actually the probability of the finding the electron. And this is the wave function we have already discussed in the previous lecture. For the energy level, this is the ground state, and the energy level 1, and there is the half wave, and then this is the complete wave, and this is the one wave plus half wave. And similarly, I will discuss further about what would be the probability of the finding electron, and how can we find out actually where is the maximum probability of finding electron in energy level 1, 2, and 3. So all these are the three energy levels as I have shown before. So we will discuss with the three energy level, and similarly you will move to the any of the energy level. So let's start with the first one, the energy level 1. Here, as it is shown over here. So this is the half wave. That means that this is the total length of the box from 0 to L. That means L is the total length, and how many waves are there in one in the first level. There are the half waves. That's why this is it is mentioned over here. This is the half lambda, And when you move to the second energy level, so there are the two half, this is one half and this is the second half. That means there are the two half mean it is the complete lambda. So you may say this is the one wave, or there are the two half wave, and two half wave are equal to one wave. Similarly, with the third energy level, there are the three halves. That means 3 multiplied by half lambda, one half, two half, and the three half. And you can say this is the 3 by 2 lambda. So this is all about what is the wave function at energy level 1, 2, and the 3. So this is more interesting, that where is the maximum probability of the electron if at energy level 1 and energy level 2, because particle is having the wave-like properties, and this is the wave, and the wave is moving from 0 to L, and this is the half wave. And where is the maximum probability of finding the electron in energy level 1? And it is shown over here. Again, this is the box, and you already know that this is the psi, and which is showing the wave function, and psi square is the probability of the finding electron. And let's see, start with the sorry, this is the generalized form. You may put any value of the n for the energy level 1. N is the energy level. So for the first, if you put the 1, this would be half lambda, and for the 2, this 2 by 2, that means equal to lambda. And similarly for the 3, 3 over 2 lambda. Similar, this is a generalized form. You may explain another way to find out the what would be the wave uh, in the in any of the energy levels. So this is the probability of the finding electron. So how I have written over here, this is the x mean x is showing from 0 to L, and between 0 to L there is any of the L. So this is the half of the L. That's why over here, what would be the value of x? X would be equal to L by 2. That means this is the whole L, and when you divide in two equal parts, this at this position it would be L by 2, and that means x will be equal to L by 2. So this is the maximum probability of finding the electron at energy level 1 is where x is will be equal to L by 2. That means half of the length of the box. So you can only divide energy level 1 into two equal uh, halves. That means each half would be equal to L by 2. That means this is L by 2 and this is also L by 2, and when you joint you will get the value of, that means total length would be L. L by 2 plus L by 2 will be equal to L. So let's move to the second energy level. So here you will find each half uh, is x will be equal to L by 4. That means you if you divide into two equal parts, there is one half, second half, third half, and the fourth half. So that's why the total x will be equal to L by 4. That means if you add up L by 4 plus L by 4 plus L by 4 plus L by 4, that will be equal to L. So, or in other way, if you divide L by 4, so that would be equal to, each half will be equal to L by 4. So in a two way, you can calculate the value of the x. So here, now I'm going to find out where is the maximum probability. Here, this is the first position. This is the 0, and when you move over here, this is the maximum probability. Here, that is the maximum peak. That means the area under this one is the maximum. The maximum probability of finding the electron in energy level 2 is at when x will be equal to L by 4. That means L by 4 is here. So this is the L by 4. Again, this is second will be 3 L by 4. So this is 0. This point is XL by 4. And similarly, you can add up L by 4. This point would be L by 4 plus L by 4. That means 2L by 4. So 2L by 4 mean L by 2, and this is the same position over here because it is L by 2. And then this position is 3L by 4. It is written over here. And again, when the electron moves over here, this would be the 4L by 4. And 4L by 4 will be equal to, that means L. So because 4 divided by 4 will be cancelled out, and you will get the value of L will be equal to L. So again, just have a look. I have just divided this whole length into 4 with 4, so it will become L by 4. So each half will be equal to L by 4. L by 4, this is the 2L by 4, this is 3L by 4, and this would be 4L by 4. So where is the maximum probability? This is over here it is a 0, over here it is a 0. The maximum is here, and the maximum probability of the electron is over here. So what is the position of X over here? This is the L by 4, and this is the 3L by 4. So if I ask what where is the maximum probability of finding the electron in energy level 1, energy level 2, so you say it is at where X will be equal to L by 4 and X will be equal to 3L by 4. So there are the two positions here. At energy level 1 there is only one position. Similarly, you can further move to the third level, and third level would be the here, and you can if you get the point over here, the first is I have divided into two parts, and here I have divided into the four parts, and here you can find there are the three peaks, and you can divide it into three. That means into three, if you divide each half into two, that means three is divided into six. So each half will be equal to L by 6. So where is the maximum probability? Maximum probability over here, again over here, and this is over here. So this is the maximum probability of finding the electron at energy level 3. So now you have to calculate what is the position of the X, or the position of the electron at the X over here, at this point and this point. So similarly, these are the three peaks I have divided into halves, and it will, each half will become L by 6. So let's start with the first. At this point, starting with the 0, and when it jumps to over here, this will become L by 6. X will be equal to L by 6, and then this position is will be 2L by 6. 2L by 6 mean L by 3. Similarly, and what would be this position? This position would be 3L by 6, because this is the X by 6, L by 6, 2L by 6, and this will be 3L by 6. And similarly, this position would be 4L by 6. 4L by 6 mean L by 2, and then when it jumps over here, this position would be 5L by 6, and again when the electrons move over here, this will become 6L by 6. 6L by 6 mean that is L. So if it is at the end, if you add up all these halves, and you will get the answer of L. That means you have rightly done with the probability of the finding electron, or you have rightly labeled the position of the electrons at all of these values. So this is the How you can find out the probability of the finding electron at energy level 1 and energy level 2, and so on, energy level 3 and so on. So these are the wave function and these are the probability of the finding electron. Again, this is very, very important, and now this is the permanently established. When the electron would be at energy level 1, and it would complete half of the wave, and the probability of the finding the electron would be at position half of the length of the box, that means at L by 2, and it is just the peak of the this amplitude. So maximum probability is at the over here, the peaks of this uh, wave, and similarly at the second position, because this is the two half and two half, just this, if you have a keenly look over here, this is just the opposite to the wave over here, because this is the positive, this is the negative, and the amplitude will become positive over here. These are the three halves, and this negative will become the positive, and this would be over here. These all would be the three halves of the probability of the finding the electron, and the maximum probability at the peak position over here, and similarly over here and here. And this is all about how can you actually label the position in a box to find out the probability of the finding the electron as well as the wave function. So moving to the quantization of the energy, I am just completing one half into the lecture, and then we will further discuss in the next class. Actually, I have already derived this equation in one of the previous lecture. So in the previous slide, we have derived the generalized form of the length of the box will be equal to n lambda over 2, as it is written over here. The length would be n lambda over here, and n is the any of the energy level, which may be 1, 2, and 3, and so on. So this would be the n lambda over 2, and n would be any of the energy level. And if you want to get the value of the lambda, just to rearrange this one, this equation, you will find out the value of the lambda will be equal to 2L over n. And according to the de Broglie equation, the wave-like properties of a particle, and this is the wave like properties, and this is the mass of a particle, both are related to each other. This is actually mass into velocity is the momentum, which is called the rho. And comparing these two equation, this is one of the equation, lambda will be equal to this, and this is also lambda would be equal to this. That means this will be equal to this one, and it is written over here, 2L over n will be equal to h over mv, mass into velocity. And if you want to get the value of the mass into velocity, that would be equal to nh over L, just to rearrange this equation. And then to find out the kinetic energy is equal to half mv square. And when you just multiply and divide with the m, just to get the value of the mass into momentum, and this equation will become this, because I'm multiplying and dividing with the m. So there is no difference between this equation and this equation, because you are multiplying and divide with the same factor. If you divide an equation, let's suppose with the 2, and multiply with the 2, there is no change in the equation. If you divide multiply with the 100, there would be no change in the equation. So similarly, if you divide any of the factor of the parameter in with the equation, there would be no change in the equation. So this equation will become like this, and by taking the square root of the momentum, and this is the momentum we have already derived by comparing the de Broglie equation and in this equation, and this equation will become like this. So just put the value of this momentum over here. That's why I have multiplied and dividing with the m, just to it would be easier to put the value of mass into velocity square or the momentum square over this equation, and this equation will become like this. So E would be n square h square over 8 ml square. So this is the actually the quantization of the kinetic energy. And see important over here, this is also one of the in the lecture, the links are mentioned over here. We have already derived the equation by solving the Schrodinger wave equation uh, with the restriction of a particle in one dimensional box, and where we already derived this equation, and to calculate the value of actually the k over here. You remember, if you have any difficulty, just watch these videos again to find out the value of the E. So this is the energy of the nth level. So just have a look on these two ways. This is the one way, which is also giving you the energy of the nth level, that would be equal to n square h square over 8m square. And in this derivation, which is another way to calculate the energy, that is the quantization of kinetic energy, that this is the same equation as it is mentioned over here. So this energy is the energy of the nth level. That means any of the energy level of when the electron move from energy level 1 to energy level 2. So these are the two ways to find out the quantization of the kinetic energy, or the energy of the nth level when the electron jump from any of the level, from energy level 2 to energy level 3 and so on. So you can find out the difference in the energy level. So I am just ending over here. So it would be better you would learn all these points and watch this video again. So in the next lecture we will find out uh, the generalized form to calculate the difference in energy levels when the electrons move from energy level 1 to 2. So what would be the generalized equation, and how can we calculate the difference in the energy level? So with this, I am going to end the lecture.